Section 10.2, products and quotients of functions. So you need your yellow sheet so you can see your graph, pretty big. And your task before class, there's a couple video examples I'm going to do later, but your major task is to fill out this table. Okay, so it says that we have to say when x is -4, so when x is -4, I need to know the value of these functions. The top one, oh, sorry, this one is f of x, and this one is g of x. You guys have that written on yours already. Okay, so g of x when x is -4 is -3, and f of x is -6. P of x, it says right here, P of x is the product of f of x and g of x. So we go -6 times -3 is +18. Q of x is the quotient, so we divide. -6 divided by -3 is 2. So your task is to fill out this table, have it filled out before class. It's just reading values from the graph. Okay. We'll do the rest of these pages together in class. Now I need you to find this page in your notes. We're going to do a couple examples. Okay, the product of two functions can be written in two ways. So I just chose h of x as, I just named it h of x. I could have done p of x. I could have used any letter instead of h. That's just what I wrote. So we can multiply two functions together. We can either write it in that way, or another way I could write it is f dot g of x. These mean the same things. It means we multiply the two functions together. Quotient can be written in two ways as well. So I'm going to use q just for quotient. So I can either say it's one function divided by another function, or I can write it in this way, f over g of x. They both mean the same thing, we divide. When we deal with quotients, we have to be very careful. The denominator can never be 0. So that's where we're going to pull in some of that information we got from chapter 9, where we have things like points of discontinuity and asymptotes. The domain of a product or quotient of functions is the domain common to both. But the domain of the quotient must be restricted, I spelled restricted wrong, to include the values, I spelled values wrong too, where g of x is 0. So I can't have 0 on the bottom. I can't divide by 0. So we're going to have to restrict the domain. And the range can be determined by using a graph. Okay. So here's an example of a problem. F of x equals x plus 2 squared minus 5, and g of x is 3x minus 4. What we're going to determine is the product. So another way of writing the product is we could say f dot g of x. Okay, I want to take some power of prediction here. F of x equals x plus 2 squared minus 5. This is a parabola. This is actually in vertex form. It's going to be concave up, and its vertex is at -2, -5. So I have a quadratic. Sorry, it's at -2, -5. So something like that. Okay, I have some parabola. I'm going to multiply it by linear. So I have some line, 3x minus 4, something like that. Well, when I take a quadratic and I multiply it by linear, my highest degree is going to be cubed. So when I'm all done, I'm going to have some sort of cubic graph. It's going to be a positive cubic graph because both of my leading coefficients are positive. So a positive cubic graph starts in quadrant 3 and ends in quadrant 1. So I'm going to have some sort of cubic. It's going to look something like that when I'm all done. That's my prediction. Okay, so let's see what happens when we multiply these together. So I'm going to take my function f, and then I'm going to multiply that by g. So the first thing I'm going to do is work inside these square brackets and expand this. X plus 2 squared is x squared plus 4x plus 4. And then I still have this minus 5. I'm going to multiply that by 3x minus 4. If you'd like to do the multiplying by yourself, you can pause and keep going, or if you want to follow me, you can follow with me. Okay, this becomes x squared plus 4x minus 1, and I'm multiplying that by 3x minus 4. I'm going to have to distribute. First of all, I'm going to take 3x and multiply it by each term, and then I'm going to do the same thing with the negative 4 and multiply it by each term. Okay, so when I'm all done, I'm going to have 6 terms, but then I might be able to combine some of them. Okay. So this would be 3x cubed plus 12x squared minus 3x. Okay, that's those first 3 terms. Now I'm looking at applying the negative 4. So that's negative 4x squared minus 16x plus 4. So now I'm going to collect like terms. I'm going to go in descending order. I'm going to do cubes, then squares, then linear. 3x cubed. Okay, I've taken care of that one. My x squareds. 12 minus 4 is 8x squared. Then I have minus 19x plus 4. Okay, so here is my product. So I guessed that it would be cubic, and it is. I had guessed that it would have a leading coefficient that is positive. So it's going to start in quadrant 3 and go all the way to quadrant 1. Okay. So f of x, the domain. So remember what f of x was? It was a quadratic. That quadratic is going to have a domain that x is a member of the reals. Its range, however, remember I said it was concave up, and its vertex was at negative 2 and 5. So that means that all the values are going to be above right here. So all y greater than or equal to negative 5. Okay. G of x, we said that was a line. Well, in a line, the domain is any real number, and the range is any real number. Okay. Now its product. I said that its product is going to be anything that's in common between f of x and g of x. Well, since they're both any real numbers, it's also going to be any real numbers. Okay, and its range said we could find from the graph. Well, I already told you that this graph is going to be a cubic, starts here and goes there, something like that. Well, think about that range. It is going to hit every single y value. And I got that from the graph. So if you don't know what a cubic looks like, what we could have done is we could have subbed this guy in and actually looked at the graph of 3x cubed. We could have looked at the graph of that to get the range. Okay. Okay, I want to try one more problem with you. Given the functions f of x squared plus x minus 6 and g of x is 2x plus 6, what I want you to do is g over f of x. I want you to find the quotient. So notice g is on the numerator, so 2x plus 6, and I'm going to divide that by x squared plus x minus 6. This should look very familiar. This is similar to what we were doing in chapter 9. So I'm going to see if I can factor this. If I take out a 2, I have x plus 3. On the bottom, I need to find two things that multiply to be negative 6 and add to be positive 1. Okay, so we should see already that we're going to have something cancel out, but I need to think about my non-permissible values. Well, x cannot be negative 3 and x cannot be 2. So what happens at each of these points? So this one is found in both the top and the bottom, so this is a point of discontinuity. Okay, this one is only on the bottom, so this is going to be an asymptote. Okay, so now let's cross out, and this graph is going to look very similar to 2 over x minus 2. Now I need to sketch this, all of these graphs on the same axes. I'm just going to do the quotient right here. Okay, so it's going to look like 2 over x minus 2. I already said that I have an asymptote at 2. Remember I said whenever we do rational functions, we always compare them to the graph of 1 over x. Well, this is just like 1 over x, but we've changed the a value. Our a value is 2, which means we've stretched it. And I also have an h value of 2, which means we have gone over 2 to the right. So remember 1 over x looks something like this. That was that base graph. So we've taken this graph, we've stretched it by 2 and moved it to the right 2. So we haven't done anything to the asymptote here. That stays. So when we are 1 away from this asymptote, normally we'd have a point at 1, but we've stretched it by 2, so we're going to have a point at 2. Similarly here, when we're 1 away, normally we would have the point here, but we stretched it, so it's gone to 2. Okay, so that's given us just about all the information we need, and now I can draw the graph. And remember, this is just a sketch. It's not a very good drawing. We could find actual points if we wanted to. One other thing is missing. We have a point of discontinuity at negative 3. So when x equals negative 3, we should have a point of discontinuity, an open circle right there. Okay. Finally, I need to state the domain and range. Well, it's x cannot be negative 3 or 2. That was from our non-permissible values. But otherwise, x could be any real number. And the range is y can't be 0. Y is a member of the reals. That is our range. So if you think about this, there's no way that I can get 0 here. 2 divided by what gives me 0? There's no way I can get that value. Okay? So for tomorrow, or for Monday rather, make sure that you have this table filled out right here.